So quadratics, parabola, same thing. Standard form is this: y equals ax squared plus bx plus c. You only need the ax squared. You do not need the rest of them. It says where a, b, and c are real numbers and a cannot be 0. What that means is you need just the x squared. The parent function, now if we're talking about the parent function of a parabola, instead of using the letter y, we've got to say f of x equals, and again, all you need is x squared, so it's f of x equals x squared. We're going to graph that in a second. Okay? The graph is a parabola. You have to know that, and you have to know parabola means a U shape. Always include a table of values. You need at least 7 points because there's going to be symmetry, which means there's going to be 3 above, 3 below, and then the one in the middle is going to be your turning point. So look for symmetry in your range. You have to know what that word range means. What does that mean?
Y.
The y. Very good. You guys are y value. Sometimes the interval to use as your domain is given. What's your domain mean? X values. Good. If they give you your domain, like here's an example where they give you your domain. They use it like this, between -2 and 4. And you got to know to start with -2 and write all the numbers till you get to 4. This is called a restricted domain. What does that mean? It means that you do not put arrows at the end. Do not put arrows at the end when it's a restricted domain. So if I'm graphing this, there's no arrows, just dots. Because I said all I want is from -2 to 4. Okay. Let's take our first example here. We are going to have a table. Instead of x, y, we're going to call it x, f of x. And I train my brain to, every time I see an f of x, to write a y above it. It will help you because your brain has been taught just y for so many years. It's really hard to switch to f of x. See, I knew you'd remember. Okay. So over here in the middle of this graph, I want you to put a box here and use one of your colored pencils. And then I want you to go over here and box in the vertex. That's your vertex. The middle of this graph. We will teach you algebraically how to find the middle, but the middle is always, you can always find it, most of the time you can find it in your table too. Okay? So let's go ahead and plug it in our calculator. Everybody should have a calculator. Go to y equals. Clear out if there's stuff in there. There should be because our last class did it. Is everybody with me with their calculator? Jack. Calculator? You got a calculator? You do? Okay, good. All right. So we have x squared minus 2x minus 8. X squared minus 2x minus 8. Good? All right, graph it. There you go. Go to second in table. And now we're going to look for our pattern. We almost have our pattern. So you're going to go up to -2, down to 4. And there's our pattern, there's our middle. 1, -9 is our middle. We're going to go from -2 to 4. So here we're going to start up here, -2, -1, 0, 1, 2, 3, 4. And I know my vertex or my turning point is 1 something. I think it was 1, -9. Okay, my y values are 0, -5, -8, -9. 0, -5, -8, -9. I only have to memorize those first 3 because then the last 3 just repeat. This is going to be -8, this is going to be -5, and that's going to be 0. So let's graph our vertex first. All right, our 1, -9. 1, -9 is right here. We're going to label that vertex with a V. Now, the next most important thing you need to know is that through that V, or vertex, we are going to put a dotted line that goes straight up through it. What's this called again? Who can tell me? Axis of symmetry. We're going to label it AOS. And the equation of this line, it goes through 1. This is x equals 1. And put it up here. That's why this little box is so important. Does everybody see that? This part, I'm just going to do it little up here. This is the axis of symmetry under here, x equals 1. The whole thing is your turning point, or TP. TP? Yes, TP. I know, you guys think toilet paper when you think TP, right? Yeah. Or TP, yeah. All right, so that little box shows us our axis of symmetry and our turning point, which is what they ask a lot of on the Regents. They ask you for those questions. Now we're going to do our roots next. Our roots are also called our zeros. So we look where the y is 0, and it's in 2 spots. It's at 2, 0. We're going to graph our roots first, -2, 0, and 4, 0. And we're going to label them R1 and R2. Now, when we actually list our roots, we can't list -2, 0, and 4, 0. We have to list x equals -2, x equals 4. Okay? Now, it looks like we can almost graph it without doing any more points, but we do have to put other points in. So let's go and graph the rest of the points that are left. We graphed the first one already, -1, -5. 0, -8. Now, some people say, oh, I can just, this one here is 1 away from that line of axis of symmetry, so I'll just go 1 on the other side. This one is 2 away from the line, so I'll go 2 on the, you can do that, or you can just do every point. -1, -5, 0, -8, 2, -8, 3, -5, and just make a smooth curve and arrows on both sides. If you don't have dots and you just sketch it, it'll be a whole point off your Regents, which is many points, not just 1. And then label your graph. I'm not going to label it because we have a lot of things, but I'm just going to put an arrow there. You need to label your graph because we have a lot of things to write on this. So, is the vertex a maximum or a minimum? Maximum means it's at the top. Minimum means it's at the bottom, so it's a minimum. The end behaviors are the directions the arrows are pointing. We always have a right and a left. The arrow on the right is pointing up. The arrow on the left is pointing up. They're either going to be both up or both down. You could write the word up there if you'd like. These next 2 questions are the toughest. The increasing, decreasing thing, and the positive, negative thing. Okay? This is where you're going to need your colored pencils. So here, I'm just going to put my, just like when you read, when you were learning how to read, right? The teacher had to teach you, or to start at the left and go to the right. Or if you were in pre-K or read books at home, right? When you learned how to read, you always your mom put her finger on the left, and then you guys went right over to the right. So same thing with this. You put your finger at the left point of a graph, and then you say, okay, now follow it down. Which way am I going, up or down? Down. So that is the decreasing side. So you're going to write decreasing here. Then it stops here. At this point, it is not increasing or decreasing anymore. It stopped. But now if I keep going, which way is my finger going now? Up. So this is increasing. So what they do in this question here is they always kind of split it at the axis of symmetry and says when x is less than 1 is the graph increase. So less than 1's on this side. So that is going to be decreasing. Now the next one you have to know is positive and negative. The top two quadrants here, so I kind of just color this in over here. These top two quadrants are going to be positive. That's when your y's are positive. Then down here, I use a different color. Down here, these two quadrants, this one and this one, are negative. The y's are negative. So usually in a parabola, you have positive parts of a parabola and you have negative parts. Not always. If my parabola started up here, let's say, and then went this way, it would be all positive, would not be negative. So it's saying between negative 2 and 4, between my two roots, is my graph positive or negative? What is it, Lex? Between my two roots, is it positive or negative? Say it again. Negative. Good. It's down here, negative. All right. This is the last and most difficult part, and the one that's asked the most. It's called average rate of change. You know it as your old friend, slope. The slope formula is it's exactly like this. y2 minus y1 over x2 minus x1. They do not call it slope because on your roller coaster, your slope on your roller coaster is always changing. It doesn't stay the same, right? It's increasing a little bit, then it's increasing a little bit more. In a line, your slope never changes, right? So this average rate of change, the only difference is here, they don't give you the points. You have to figure out the points. It says from negative 1 to 2. So you got to make two parentheses. The first point, the first x is negative 1. The second x is 2. Then you go up into your table. It's negative 1 goes with what number? Negative 1 what? Negative 5, yep. And what goes with the 2? 2 what? 2, negative 8. So now we're going to just use our formula. But now instead of saying m equals, we're going to do this. ROC, rate of change. Sometimes they put an A in front of for average rate of change. I just use ROC, okay? So we're going to subtract our y's first. y2 minus y1. Negative 8 minus a minus 5. Over 2 minus a minus, subtracting our x's. What happens to those minuses? They change to what? Pluses. So negative 8 plus 5 is going to give me a negative 3. 2 plus 1 is going to give me a positive 3. So the average rate of change is a negative 1. That means between negative 1 and 2, between here and here, that this looks like it's going down 1 over 1. Does it really look like that? It's not exact. But this is why people that design roller coasters, remember that roller coaster they showed you in that video? There was all those supports put in there, and they look like little triangles, right? If you ever did bridge building in middle school, the bridges that lasted the most had the triangular supports in them, right? So they have to figure out where the most stress is on a roller coaster. That's where they put the most supports in. So where's the most stress on a roller coaster? Where do you think the weight is the heaviest on a roller coaster? Probably on the top, but even actually pulling up. There's different stress points, but yeah, right as you go over the top of that roller coaster, I'd say there's a lot of stress on that roller coaster, right? Yes?
Is that negative 8 plus 6 equals negative 2 and that negative 3?
That's a 5, hon. It looks like a 6. It's my funny looking. That's a 5. Yeah. Okay, so that's where they look to put the supports in for all those rides and everything. All right, let's go to the next page. So this one I'm going to have you guys try on your own. It's an x and a g of x this time. Use your colored pencils. Box in the middle. Now, they already told us this is a restricted domain. They told us what our x's are going to be. They're going to go from negative 1, so put a negative 1 there, 0, 1, 2, 3, 4, 5. I know that before I even do any work on this problem, Seth, There we go. I know that my middle is going to be, my vertex is going to be 2 comma something. I don't know what it is, but it's 2 something. Now, if I go over to where x equals 2, I can put this thing in. What's this thing called again, Miles?
Line of equal color.
Axis of symmetry. I already know what my axis of symmetry is. It is x equals 2. How do I know? Because, remember I told you, in that little box, the first part is the axis of symmetry. The whole thing is the turning point. Okay. So now I want you to finish this. Plug this equation into your calculator. Get your table. And try to answer those questions. Go ahead. I'll give you guys a few minutes to try that on your own. Pause it. That one. Okay, so let's tell me these numbers that are in this chart. Miles, can you tell me them? Mm-hmm. You got it, Maddie? You got the numbers? Go ahead. Tell me, Maddie. Uh-huh. Say it again. Uh-huh. Uh-huh. You're saying that's not the numbers?
Yeah, that's not what I got.
Okay. Maddie, I can come look at your calculator. All right, let's try again. Aaron, what'd you get?
For 1.
For -1, start at the top.
I got -5,
Uh-huh.
0, 3, 4, 3, 0, -5.
Okay, let's try. So it turns at 2, comma 4. Over 2, up 1, 2, 3, 4. Again, that's the vertex or your turning point. They want you to label it with a V. We're going to do our zeros again. Our roots or our zeros are at 0, 0, and 1, 2, 3, 4, 0. We got to label them R1, R2. And remember, you have to label them over here as x equals 0 and x equals 4. Again, you're tempted just to draw your parabola, but you got to do all your points. So let's start over here. -1, -5, -1 down to 5. 0, 0 we already graphed. Over 1 up 3. Over 2 up 4 we already graphed. Over 3 up 3. We already graphed our root. And then 5, -5. And because this is a restricted domain, no arrows at the end. Is this one a max or a min? Max. All right. Now I'm going to have you guys do 2 more on your own. Okay? So you're going to plug this equation into the calculator. They want to know which one of these points is on that parabola. Then you're going to plug this equation into the calculator. And I want to know which one of these points is on this. Go ahead, do that on your own. I want to see everyone punch them in the calculator and show me that you did it. Come on. Plug that first equation in. Come on, Jack. Get your calculator. It's hot. Okay, so number 1, when you put it in the calculator and looked in your table, the answer was choice 3. Number 2, if you put it in your table, look in the calculator, it's choice 4. Number 3, the answer is narrower because 2x squared when you plug it in looks like this, and and the other one, 1/4 x squared, is a wider parabola. Number 4, the answer was negative. Negative are the ones that turn down, so f of x and g of x. This one, when you put them in your calculator, y equals x squared, and this one, you will see that one parabola will be right here in the center,